Kubernetes is a fully API-driven system, and at the center of it we have the controller pattern. What does the controller pattern for us? It ensures the reconciliation by observing the desired state and adjusting the current state for our objects. It does the drift correction more exactly. We have the kubectl manager component that runs in the control plane, and actually it has various controllers for us. Now, if we decide to create a deployment in the default namespace with 2 replicas, of course we're going to have 2 pods, and as we said in the kube system, if we grep for controller, we can see that we have our kubectl manager. And even more, if we check the logs of this component, we can see that the replica set controller is the one that spins up the pod for us and ensures the number of pods. This means that if we decide to delete one of the pods, let's say the second one, the replica set will kick in and get pods, and it will start a new pod in our default namespace. Now, almost every object in Kubernetes has 2 nested fields, the spec one. So if we take a look at the pod object, we can see that we have the spec field that represents the desired behavior for our pod, and also we have the status, which represents the current state of our pod. So these 2 nested fields are being used to ensure the reconciliation and drift correction in our cluster. Now, when we do a kubectl get pods, and if we increase the verbosity, we can see that the API that is being reached is the API endpoint is the namespace default pods, and we can create the raw request for it and grep for our pods, and we can see that we also can get a more verbose information as JSON if we create the request directly to this endpoint. So basically the pods are objects in our cluster, and they are a resource type for our cluster, for our API, so to say. So in high level terms, this is the core idea behind the control pattern.